Hello students, today we will see time response of first order system. In last lecture, we have introduced the term of transient response and steady state response. We have seen the standard test inputs. Okay. Now we will see the effect of input on the output by applying various standard inputs. Okay. Now before starting, here the title is given time response of first order system. Okay. So first order system means you have to check the denominator of the transfer function. Okay. So highest power of s in denominator should be 1, then you can say that first order system is there. Okay. We have seen the first order system, second order or higher order also. But today we will discuss with the time response of first order system. Okay. Now see here. Here this is the block diagram. Okay. Here g of s is given as, this is g of s. Okay. So g of s is given as 1 upon s tau. Okay. Tau is nothing but the time constant. And you can check h of s is here unity. Okay. So unity feedback system is there. So what we need to do, we have to calculate the output response. So when I am saying output response, so I need to calculate C of t. Okay. See, in previous units we have calculated the transfer function or we have the characteristic equation, but here what we need to do, we need to obtain the output response. So that will be in time domain. So you have to take Laplace inverse of C of s, then you will get C of t. Okay. Now we will see how we are calculating the output response. Now look at this. This is the block diagram. I know how to calculate the transfer function from the given block diagram. So this is C of s upon R of s. Now this term, it will be G of s. Look at this. This is G of s. I have substituted plus upon 1 plus, this will be G of s into H of s. Okay. So I have substituted here G of s. H of s is unity. Okay. So I got the transfer function as 1 upon 1 plus s tau. Okay. Look at this. Here tau is a time constant. Okay. You can rearrange to get in the form of s plus also. So if you will rearrange, definitely what you will get, it will be in the form of 1 upon s plus 1 by tau. Okay. So what you have to check? You have to check the highest power of s in denominator. So what is power of s in denominator? Here power of s is 1. Okay. So what will be the order of the system? This is first order system. Okay. Now see what we have to do. This transfer function will be fixed because what we are doing, we are just assuming the block diagram for first order system. So we got the transfer function. Now we will put different inputs and we will check the output. Once you will calculate the output, we will check the error also. Okay. So how the error is varying by the variation of the input. Okay. Now look at this unit step input. Okay. We have studied first standard test as a unit step input. Okay. When I am saying unit step, so R of s is 1 by s. Okay. So R of s is 1 by s means R of t, here it will be 1. Okay. We have studied. So see what I will do. Here C of s upon R of s is there. Okay. Look at this. What I did here. C of s is equal to, I have substituted the value of R of s as 1 by s. Okay. So here C of s, I will multiply it with R of s. Look at this. I have substituted R of s as 1 by s. Okay. So now I have rearranged in the form of 1 upon s, 1 plus s tau. Same transfer function. Only I have multiplied it with R of s. Okay. So see, I have this transfer function. What I have to calculate? I have to calculate C of t. For that I need to take Laplace inverse. Okay. So you know that for calculating Laplace inverse, this transfer function should be arranged in partial fraction form. So look at this. This I have arranged in partial fraction form. So 1 by s minus 1 upon 1 plus s tau. I hope you know this partial fraction form. Now see here, I have taken the Laplace inverse of this C of s. Okay. So after taking Laplace inverse, look at this C of t, Laplace inverse of 1 by s, it will be 1. Laplace inverse of 1 upon 1 plus s tau, it will be e to the power minus t by tau. Okay. So I got output as C of t as 1 minus e to the power minus t by tau. Okay. Now see what I have written here. I have written the error. What is error? Error is e of t is equal to input minus output. Okay. So what is input here in time domain form? That is 1. I have substituted. C of t we have just calculated. So I have substituted the value here. Look at this, 1 minus in bracket 1 minus e to the power minus t by tau. Now what I got here, e of t I got as exponential form. See, I got error as e to the power minus t by tau. Okay. So please remember what I have calculated. I have calculated c of t from c of s. Then I have calculated error after substituting the value of input and output. Okay. See, from e of t we can calculate steady state error, that is ESS. Okay. So what is ESS? ESS is nothing but limit t tends to infinity into e of t. Okay. See, this we will see in second part of this unit. Okay. You can calculate steady state error also from e of t by taking limit t tends to infinity. Okay. We can calculate steady state error. But look at this now. Second we will see. First we have calculated this is the output response when we are substituting unit step input. Okay. So next standard signal we have studied as ramp signal. I told you that when slope it will be 1. So that is called as unit ramp input. Okay. So look at this unit ramp input. Same I did here. R of s I have substituted 1 by s square. In previous I have substituted R of s as 1 by s. Okay. Here this is unit ramp, so I have substituted R of s as 1 by s square. So R of t will be definitely t. Okay. So now see, the same thing I did here. I have considered same C of s. Look at this. I have considered same C of s. But here I have substituted 1 by s because I have considered R of s as 1 by s. Now what I will do here, look at this. I have substituted here 1 by s square because R of s is 1 by s because I have considered unit ramp. Okay. Now see how the thing will change. The transfer function will definitely change if we will substitute the different value of input. Okay. So I got this transfer function here. Again you can check that here I have rearranged that transfer function in partial fraction form because I have to calculate C of t. Okay. So look at this. Here I have rearranged that. You can arrange using partial fraction form, just a by denominator plus b by, it depends. Okay. So look at this. Here I have rearranged and I have taken the Laplace inverse of C of s. So what is Laplace inverse of C of s? I will get here C of t is equal to. Okay. So after taking Laplace inverse C of t, it will be, look at this, Laplace inverse of 1 by s square, it will be t. Laplace inverse of 1 by s, tau is constant. So this will be tau plus, look at this, again tau is constant. This is in the form of 1 by s plus a form. So this will be definitely e to the power minus t by tau. Okay. So I got C of t when I have substituted unit ramp input. Okay. The same thing I will do now. Once I will get the output, I will substitute in the error formula. So what is error formula? E of t is equal to R of t minus C of t. Okay. So input is t. I have substituted t here. This is t. Okay. Then I have substituted C of t, whatever I have calculated. So what I got here? I got error. E of t as t into 1 minus e to the power minus t by tau. Okay. So this is error with unit ramp input. Okay. Now the last one is left, that is unit impulse. We have studied unit impulse. We are getting infinite response at t is equal to 0. Okay. So what we are doing now, next I will consider or I will check the output response for unit impulse. So R of s I got as 1. Okay. As we have studied, delta t is equal to infinity. So look at this. This is my C of s, same C of s. See here, C of s is equal to 1 upon 1 plus s tau. See, I will multiply this one with R of s. What is my R of s? R of s will be 1. Okay. So after substituting R of s as 1, I got, or I have rearranged this term 1 plus s tau as 1 upon tau s plus 1 by tau. Okay. So next I need to take the Laplace inverse of this C of s. So I have taken Laplace inverse. Look at this. So again this is in the form of 1 upon s plus a. So this is 1 by tau is actually the constant. So 1 by tau e to the power minus t by tau. Okay. So last I need to take, I will calculate e of t, that is error as input minus output. I have substituted, as you know that r of s is 1. So definitely r of t I need to take as 1. Okay, that is for impulse. So e of t, it will be 1 minus 1 by t to the power minus t by tau. So see, this is the way actually we have calculated the error from the output response c of t. Okay, but what we need to remember here, we need to calculate the steady state error, that is ESS, with this formula, whether that error is increasing or decreasing. Okay, I will tell you the one more thing, that is called as time invariant property. What is that property? Suppose I am just writing here c of t as c1. This c1 is nothing but for unit step. Okay, so next for unit ramp I have calculated c of t, so I am writing here c2 of t, and last one is for the impulse, so I will write here c3 of t. Okay, so just now I told you that that is time invariant property. So what is that property? See, if you will take the derivative, see I am saying c2 of t is equal to, if I will take the derivative of this c1 of t, I will write here c2 is equal to, if I will take derivative dc1 by dt, so I will get c2. Similarly, I will calculate c3 as derivative of c3. So if you know the C1, you can calculate C2. If you know C2, you can calculate C3. Okay. So that is called as time invariant property. So I hope you got the concept of time response of first order system with different standard inputs. Okay. And we know how to calculate error from the output response. Thank you, students.